So Impact Framework is all about manifest files. Everything with Impact Framework, it's a tool that helps you compute the environmental impacts of software, but it's driven via a manifest file. It's all file driven. And the way we think about it is that you calculate and compute your impacts using a manifest file, and you send that to others, and then they then can compute it themselves. So I've just been sent this manifest file from a dude called Asim, and I want to run it. I want to see what he's computed, and I want to see what assumptions he's made and how he's structured his manifest file. So this is a YAML file format. It's got what we describe it is everything above the tree we call context, the context of the manifest file. This gives you information about how to run it. So we have, name, description. We perform aggregation in the manifest file. This is the settings for that. So a lot of the settings and configuration are in context. There's an initialize section with outputs, but also most importantly, plugins. A manifest file, it's a framework. Sorry, Impact Framework is a framework. If you just installed the IF tool without any plugins, it wouldn't do anything. It's a framework which you can use to build stuff on top of. And so you build it using these plugins. Each of these plugins is just some code, and you're going to be we're going to be building a plugin later on. So you're really going to see what plugin is shortly. But this is where you configure the plugins you need to compute this particular manifest file. So I've got a number of them here, and I'll be going through these in a bit more detail later on. But you can see here there is effectively some configuration, and I'm naming these plugins so I can use them later on in my file. Now let's go down to the tree. So you can see the tree has different nodes. So we have the root node here, which is what we call the tree. And underneath it, it has children. And underneath children, I have another type of node, which I've called server one, and that has inputs. There's two types of nodes in the tree. There's what we call component nodes, and there's what we call grouping nodes. A component node is something which emits emissions. So if you can emit emissions, if it creates emissions, you would structure that as a component node. And really, it has this thing called input. So a server emits emissions, but you can structure a manifest file to compute anything, even outside of computing, to be honest with you. But in terms of computing, it could be servers, it could be laptops, it could be devices, it could be networks, it could be whatever, it could be bandwidth, it could be whatever it is. If it's something that can emit emissions, then it's a component. Component nodes have inputs. So this is what we call inputs. And this inputs is a time series of what we call observations. So you can see here, this is an array in YAML format. And you can see each array, each thing has a timestamp and a duration. So it's a time series array. So at this time for 5 minutes, what did you observe? So this is what you observed. We use there the name of the server, the instance type, some details about the team, what cloud it's on, what region it's running in, but most importantly here, the CPU utilization. The CPU utilization is the thing that was one of the most driving factors for the emissions. So this is what I can observe from from this server. So I've observed over this particular 1 hour period of time, the utilizations and things like that. And you can group these however you want. We've got almost no grouping here at all, just under a tree. But you can actually have children of children of children of children of children, grouped by region, grouped by department, grouped by whatever it is. And I'm going to show an example of that later on. Groupings is just how you want to structure the information to surface different things. There's a question, anonymous attendee. I don't know, you can have anonymous attendee. Is there a way to generate these YAML files yet, or is this planned? Are you providing infrastructure code as input? So I'll show you a little bit of an example later on. You can either generate the whole YAML file with these inputs yourself. One of our member organizations does this for their entire infrastructure, tens of thousands of computers. They manually generate a whole manifest file with all the inputs every 5 minutes, compute it every 5 minutes. Or you can create an importer which imports the data in it. I'm going to show you that later on as well, but you can type the answer as well, Joseph. I thought it was an interesting question, so I want to answer it. So yeah, so we also have this thing called a pipeline. So you can see here, you saw this configured above there. These are the plugins. So what effectively happens is we pass all of these inputs to the first pipeline plugin, and then whatever the outputs we pass to the second, to the third, to the fourth, to the fifth. And each one is doing its own little job in converting this, what we call an observation, into an impact. So each of those plugins does its own little part. Um, and you can actually have these pipelines kind of anywhere in the tree that you want. I'm putting it at the root, but at different moments in the tree, you can have different pipelines to compute different parts of the tree in different ways. That's totally fine as well. But in this example, I've just put my pipeline at the top. Now, to compute this manifest file, you actually need some software. You need something called Impact Framework, and you need to install both Impact Framework and all the plugins that are needed to compute this particular manifest file. Now, our eventual goal is to make Impact Framework kind of something you install globally, and Impact Framework handles all your plugins, installs through, and everything like that. But right now, we're not quite there yet. So Impact Framework is built with Node, and we use kind of Node Package Manager and other things like that to install it. I'm going to show you kind of how I would recommend you do it right now. So what you would do is if you sent a manifest file, just create an empty folder somewhere on your computer. You have to have Node at least version 18 installed, and you have to have npm installed, so Node Package Manager installed. And then you would go into your empty folder and you would type npm in it to initialize the folder so you can start doing Node code inside it. And then you would type no npm install grunsoft if, and that is the actual CLI tool to actually run the manifest file. But then you'd also actually right now need to go through and install all the plugins that you need to run run the manifest file. And what you need to install depends on what's in the manifest file. So at the top here, you can see that this uses this plugin, so I would need to install that one, and you need to install all those manually yourself. So you still need to do that eventually. We hope to make this whole thing a bit more automated. And then when you're finally ready, you need to run the CLI tool, and there's various ways. I like to use npx ie --manifest, and then the name of the file .yaml, and an output. And you have to put like what do you want to output as, and the like. Now, that's how I would recommend you do this. If all you ever wanted to do was build and compute a manifest file, this is the right way to go. If you actually want to build a plugin, you have to go a slightly different way, and you actually have to download the actual source code for IF. So with a plugin, it's a bit more of a complicated, a bit more slightly different approach. Because we're going to be building a plugin later on, I'm going to use that approach right now just to make life a bit easier. But that's not the approach. You don't have to download the source code for IF to run it. You can just install the IF CLI and just run it as a package without needing to like install and clone the code locally on your computer. But I've cloned the code locally on my computer. This is the code for Impact Framework. And again, the only reason I'm doing this is because we're going to be creating a plugin later on, and this is the way we recommend to do it to make the ability to build a plugin easier. So let me now actually stop talking and just run it. Okay, here we go. Static. Okay, that's the file. Asim static, Asim static. Let's give it a go. Fingers crossed. Oh, fudgings. Um, had to happen. Had to happen. Oh, I know. I know what I've done. I know what I've done. I know what I've done. Yes. Okay, brilliant. Brilliant. Let me get that working for you. So again, if you're running from the I can't type and talk at the same time. If you're running from the downloaded source code, you need to run npm run IE. If you just did it the way I mentioned previously, you just run npx IE. So because I'm running it locally like this, I'm going to run this. It's the CLI tool is called IE for Impact Engine. That's the actual name of our CLI tool. Impact Framework is the whole framework, but the CLI tool is called Impact Engine, and it's not Internet Explorer. Some questions here while I'm waiting. Oh, no, it's finished. So now it's finished. I'm going to open it up. So what it's done is I said that I wanted to output to a file called computed. And there's some stuff here which I'll explain in a second as well. So it's now generated a file called computer.yaml. So let me see what that's done. And what I'm going to do is, yeah, let me zoom out a little. I know you can't see it. So you can see I've got children, I've got server one, and it's got inputs, but now it has outputs as well. Let's have, again, a quick look at inputs. You can see there was just a little bit of inputs there. And then now let's look at what the outputs to that server is. And you can see there's a lot more outputs, but more importantly, there's a carbon value at the end of it. And again, what happened was when we ran, it took these observations and just the same way as you have a Linux command line where you join different small commands together with a pipe operator and you can do very complex operations. That's exactly what we're doing here. Each of these is a small little unit of code which by itself is doing one job and one job only in helping to turn that observation into an impact. And so what's happening is we're passing this data to the first plugin, then the second and the third, and whatever that outputs, and we pass it along. And the outputs of the last plugin is basically this. So the output of the last plugin is all of this with carbon at the end of it. And that's a process we call induction. Is that process of taking an observation and converting it into an impact is induction. And we do that with a pipeline of plugins. And it's really oh, let me also, before I go too far into that, talking about the conceptuals, let me also explain here. So one of the things we've done also is we're also outputting to a CSV file. And if you remember this is a bit clunky right now. We will be changing this shortly, but I'm also saying I just want to output the carbon metric, not all of it, just the carbon metric into a CSV file. And we do this because it actually makes it a little bit easier to understand what's going on and what the impact framework is doing. So you can see here, server one, server two, server three, server four, server five, dot carbon. And this aggregated column is the total carbon for that hour. It's an hour period of time where we've got in the manifest file. And you can see server one was 112 grams, 104 grams, 103, 99, 123. And aggregated, this cell is the total, let's say that my entire application for this period of time has emitted 553 grams of carbon. But it's not just that, because we do it time by time as well. So we can see for every 5 minute bucket of time, for each server and for the aggregate and whatever grouping you have, it's a tree structure. So however you group it will, and I'll show you this later on as well, it'll surface this up. So you can see for this 5 minute period, 28, 31, 35. Is there a one that's particularly higher? Well, this one's 51, so that's particularly higher. So you might then go, well, that's particularly high for that time period. Let me dive into that time period. Which component, which process, which server for that time period was the highest? And that's kind of one of the things we do. We're not just measuring for measuring's sake. We want to measure because we want to surface insights that you can use in order to identify where your emissions are coming from, where effort needs to be spent. That's a really important part of Impact Framework. And that's why we put so much effort into measuring as granular as we possibly can, not just the aggregated top number, which doesn't tell you too much, but where did those emissions come from? That's what's really important here as well. Let me make sure I've mentioned everything. Yeah. And so just coming back to here. So again, we're passing this thing through this. The process of induction is taking an observation and passing it through a series of plugins to get the emissions. Impact, as I said before, Impact Framework is nothing without plugins. So we have a number of plugins that we've baked into the Impact Framework, some that we've released in what we call our standard library of plugins. Those are plugins that we commit to maintaining. We also have this library called the unofficial plugins. And those are plugins that we've built, but we honestly, hopefully, other people will take over one day because we've built them for other organizations. And so you can see here the plugins at the top. This is where we configure them. This is a built-in plugin. This is one of our standard library of plugins. It's just multiplying things together. This is one of our unofficial plugins because we built a plugin for an organization called WhatTime to get the WhatTime grid emissions data. So these are just various plugins that we're configuring in at the top. Very quickly, you can get to the list of plugins by going to the documentation site, head to Docs, head to Reference, head to Plugins, and there you'll see the full list of plugins that we've got right now. And then if you click on a plugin, it'll take you to the GitHub page, and there you'll find documentation for that plugin, how to use it, how to configure it, even some of the source code that's involved, an example manifest. So that's where you find information to which plugins can you use when you're building up your manifest file. Okay, I'm doing okay. And just kind of like finally, let's take a look at the actual computed file. Now, this is something we firmly believe in, is that you're not just sending people like your aggregated that top level 400 grams of carbon. We hope you can do that. That's a use case for Impact Framework. What we hope people do with Impact Framework is make sustainability transparent. This manifest file is everything. It's all of your working out. It's all of your data. It's all of your coefficients. It's all of your models. Everything you need to compute the emissions is stored in this manifest file. So send that manifest file out to people. Say like, this isn't just what we computed. This is all of our assumptions. So you know what we've done. You can compare and contrast properly. You can challenge. You can say, maybe you send it to a regulator and they go, well, that's interesting, but we need you to use these official plugins and we have to use these official coefficients. You can't use yours. You're like, okay, great. Edit them. Done. That's your manifest file for your type of emissions calculation. It's all about transparency. We truly believe this space, the solution to this space, it starts with transparency. It's too opaque right now. But let me move forward. So a really interesting thing about this manifest file is it's not just a record of emissions. It's not just a record of, oh, this is how much we emitted. It itself is a model. It's a model of your application. Yeah, I'll let you answer that one, Joseph. So it's a model of an application. What you've done here is you've basically modeled what your application performed in that 1 hour period. You've taken something you've observed, you've done some computation to it to generate an output. Now that means, very interestingly, that you can do scenario analysis. And from all of my experience in this space, if you really want to convince anybody to invest in any green software initiative, you can't just say what your emissions are. You have to say, this is what our emissions are. If we did X, this is what our emissions would be. And that's, again, another really powerful feature of Impact Framework. And because we've modeled it and not necessarily, more I know about this space, I don't even think there is such a thing as direct measurement. Everything's a model all the way down. It's just where do you draw the line? But anyway, other than kind of direct measurement. So let me talk a little bit about how that works and the advantages of that. But to do that, I'm going to use a slightly different manifest file. I'm going to use ASM.YAML. This is a little bit different to the one we just saw. You can see at the bottom, it doesn't have like a whole like array of inputs. It's actually just null. And that's because this one uses a slightly different type of plugin, which is what we call like an importer. So as someone asked the question earlier on, do you just have to have all those static data inside your manifest file? No, not necessarily. You can actually create a plugin which imports data from somewhere else. There's actually an Azure importer as well, which imports Azure data. Somebody just proposed a hackathon project to create a GCP importer to import data from Google Cloud. I want importers from like, can there be a Zoom importer so we know how many Zoom meetings we've had and then build some models to figure out how many of those, what the emissions of that is? Can we build an importer which gets data from um, any of these other data sources, that the observations, because by building importers, you open up the doors to what you can measure. So, but what we've built is a fake importer here. So this is something that uses what we call mock observations. So we use this a lot with testing, and we recommend if you're like exploring and you're trying things out, it's a really good way to try things out without really trying to grab too much data. Um, and it allows us to generate kind of fake data in a way that might be generated by another plugin or maybe a plugin that doesn't exist just yet. Um, yes. So, oh, when your model does not. Let's Joseph answer those questions because I've got to focus. There's the great questions, and let's make sure. I hope before we close out, Joseph, let's make sure to get all these questions as well. I don't know if we keep them in previous Zoom calls so we can put them on the FAQ, but there's a lot of great questions today. I should probably zoom forward because I got delayed. I didn't finish properly in the morning. So anyway, let me zoom forward. So so this is like uh, mock observations and it's generating a whole bunch of mock data. I won't go into too much detail, but you can see here there's a bit of the mock observations where we're generating a random integer for CPU utilization. So there's documentation for mock observations on that docs page, and I'd go read it because it's very simple to configure, but you can generate a wide variety of data using it. So we're just generating a lot of fake data for some servers running on Azure in East US of the US. Um, okay, so that's one way in which it's different. So I'm now going to run this one instead of the static one. So, oh, I want to be here. What the heck? So Asim, here we go. Fingers crossed. Come on, come on, come on, come on, come on, come on, come on. Oh, I should have done this while I was talking because it takes a little bit of time. This is a big one, and it's actually calling the WhatTime plugin, and the WhatTime plugin actually makes API calls, so it's a little bit slower because it's not using a local model, it's making some API calls, and because it's quite a largest manifest file, it might take a second. Oh, it's done. So here we go. So let me open up this one. And you can see here, I've got, yep, children. Oh, it's doing that weird thing again where it doesn't show me, doesn't collapse properly. But that's okay, because I've also outputted a computed CSV. So you can see here, it's generated a lot of fake data, but in the same structure as we had before. Um, So what I'm going to do now is this is where now we can start doing some scenario analysis. Now I mentioned before that this is generating, this is fake data, but you could build a plugin which kind of changes this on real data as well. So you can just change the cloud region. So I'm going to change the cloud region to where that was on East US 2. Eastern side of the US is oftentimes the electricity is dirtier than the western side of the US. So I'm going to just change. What if I was to migrate my entire application over to the West US 3? What would the emissions difference be? I think here you can see here it's two, two 2.3 kilos for that 1 hour period. That's what we already have. So I can't say it in now, 2,300 grams. I've now moved it to West US and now I can rerun. Have I saved? Did I save? I think I saved. Um, and what this is now doing is calling the WhatTime API because we use the WhatTime and it's doing an API call and that's getting data from that region instead of East US and theoretically the emission should therefore reduce. And I'm just talking right now. Source file changed. Here we go. 610 grams. So that is just straight up an easy way to do some scenario analysis. This is the baseline of our application. If we were to move this around and change things here, this is how the emissions would change. Maybe we should do it. Maybe we shouldn't do it. What are the trade-offs? This allows you to have those kinds of conversations. There's other things that I can do. So, for instance, perhaps I'm speaking to a regulator or my corporate reporting department, and they're like, you can't use, and oftentimes you do this with the GHG reporting, you're not actually allowed to, well, I don't know if it's allowed is the right term, maybe strongly recommended not to use real-time granular data that changes like region by region. You have to use like a global average for grid emissions, and they might say that to you, in which case you can just comment out the WattTime plugin and say, I don't want to do that. And what the WattTime plugin does is it outputs this field called grid carbon intensity, which is different for different regions and different times. I just want to set the default to 500. And this is what defaults does. Defaults is a part of the tree, and you can set defaults. And it basically just adds those defaults to every single observation. So it's just, yeah, it's a default. So this should be faster now because I'm not using the WattTime API. And there you go. And now the computed, it's gone down even more because I think it must be slightly less emissions. 500 must be less than what was averaging out there. So that's another way you can kind of play around with data. Um, other really interesting things, and this is where it depends a little on how you set it up. But we have like a group by plugin, and so what that does is it allows us to group the information in interesting ways. Like right now, it's just grouped by the name of the components, which is right, server one, server two, server three. But maybe I've added additional data in the observation, which tells me um, which application. Maybe you have like maybe it's one application has multiple servers associated with it. Which of my applications is causing those emissions? So I'm going to first group by application, and then name, and let's see what that results in. Okay, let's open up the computed. So you can see here, probably straight away, there's got quite a few more rows. And that's because I've grouped it by the database. The database has server one and server two. I've got cache application, which is only server three, and an API, which is server four, server five. So then you can see, well, maybe my API is causing most of my emissions, or you can even graph just the API, all your API servers over time, so you can see how that works. So groupings are really interesting ways that you can use to slice and dice the data. You might not want to group by application. You might want to group by region or department or whatever other metric or parameter that makes sense for you. It's useful oftentimes to group data in different ways because it might actually surface a spike in emissions at some point. So you can, why is that a spike for that region in that time? So grouping is very useful from that perspective. And there's also a really interesting feature which we call time sync. So, which is here. Oftentimes you might, just for things to like aggregate up nicely in a CSV, everything needs to be snapped to a one-time grid. You might have data which is kind of like different durations, different start end times. You might have a batch job that's really long, lots of processes. It just really depends. So what we've built is it's a very complicated feature called time sync because how do you synchronize all these variables? But it's a really powerful feature. So what I'm going to do here is with time sync, um, currently it matches what the data is. I'm going to say, do you know what? I actually want it in 15-minute buckets instead of 5-minute buckets. And you can downsample as well as upsample. So it's in seconds here. So if I rerun that, and then look at the computed, did that work? Yeah, it worked. So you can see here, hopefully you can see it's got fewer columns, and each column is 15 minutes worth of data. And you can probably notice that the emissions per server is high because it's for a longer period of time. So that's time sync as well. So this is why it's so useful to have a manifest file because you can start doing, it's not just a static report of your emissions, it's its own model of your application. And you can start then playing around with things and asking those questions. Yeah, there we go. So, what I am going to do. There's a question here. Is it planned to make it more IF more user-friendly and also more usable for non-IT people? From IF framework is designed, honestly, as a fairly low level infrastructure. It will always be either a CLI tool or it will be a software development kit which somebody uses to build high level applications. We might build a simple UI over it, but what we expect eventually is it's an open source and we're doing the hackathon. There may be people building UIs on top of it and things to make it easier, but it will not generally be what we build here at the foundation. We tend to just build the connective underlying infrastructure and allow the ecosystem to build the tooling that needs to be built on top of it for whatever the use cases that you want that you have. But we probably will build a simple UI on top of it, but nothing very complicated. Um, okay, so that's kind of like here, how do you build a manifest file from scratch, right? How do you build your own manifest file? So let's do that as well. I'm going to rush through this because I've already explained quite a lot of what's going on. I just want to show you the step-by-step process. So it's not so strange because I do want to get to the plugin writing process, which is I think really important because we don't have many plugins right now, and really most if you there will be a lot more plugins that need to be created for this to be ubiquitous. And we're really looking excited for people to start building their own plugins, especially for the hackathon. Okay, so I've started off with a very basic manifest file, my first manifest file here. There's nothing really going on here. Um, I want to do that same thing I did before, which I want to kind of like import some fake data. So I'm going to basically, in the initialize section, I'm going to add my import data plugin. It's that same as that mock observations that you saw previously. I'm going to call it whatever I want. I'm going to call it import data. In fact, you can call this is like a variable name. You can call it whatever you want. Choose something descriptive that makes sense for you in your pipeline, but the actual meat of what that is in there. And in the tree, I'm just going to have something uh, in the root of my tree, and I'm just going to call import data, call this anything. Um, there we go. Let me just now run this. I'm just going to run it one step at a time so you can see how it gets built up because I think really helps to explain exactly what's going on with the man with Impact Framework. So I'm going to do first. I'd call this first, right? Didn't I? Yes, I did. Um, excellent. Oh, did that work? Oh, it worked. Awesome. Um, and now let's go to here. This is the import. I always make the same mistake. So here we go. So you can see that what's happened here is it's basically the import data, call this with anything, generated these outputs, and that's what's now in the outputs. I've got some CPU utilizations of I know the cloud render, I know the cloud region, I know the cloud instance type. How do I convert that into an impact? So you're like, well, what do I need? What is the next plugin in the pipeline that helps me to induce my observation into an environmental impact? So one plugin that is very useful, especially working in the cloud infrastructure, is a plugin that we maintain called Cloud Metadata. It's a common issue. Every single model out there, not just impact frame models, all models, everybody's trying to like um, everybody has to have metadata about cloud infrastructure in order to build up their model, but they're kind of varying levels of out of datedness. So we decided to maintain our own, and all it does is metadata about cloud. It's not trying to do anything else. It's just metadata about cloud, and we're maintaining this ourselves. If there's any issues with it, please raise a pull request, and we'll fix it. So cloud metadata basically takes some of that information and just enriches it with other information which is useful to you in computing the emissions of your software. So let's rerun that again. I've done it again. Every time. Every time. Every time. I edit the output file. It was cute. It was honestly cute the first few times, but now it is annoying me. Maybe we should build a feature to stop it from to warn you or something. I don't know. Um, Cloud metadata here. Here we go. Okay. So let's have a look at computer YAML. And now you can see the outputs have just more information. And that's because it's been passed to cloud metadata, which has enriched it. Now it's enriched it with things like the number of CPUs, the amount of memory, the processor that that server contains. Very importantly, the thermal design power, which is what you need in order to compute. Um, it's a value that you need in order to compute the energy consumption of a server for a given CPU utilization. We also have returned like useful information given where the server is based. So we know the cloud metadata also returned the grid it's on, the location, the geolocation of the data center. These IDs were used for other services that you might find useful. So now we need to kind of like take it a step further. I actually want to calculate I'm in the computed. There we go. I want to compute the energy, and for that, I'm going to use a model which we call Teeds curve, which is a quite common model that people are using. It has deep limitations, deep limita deep limitations, but it is very general purpose and it works in Lobby. All it needs is a utilization and a TDP, and it works. So I'm not going to add that into my pipeline, and let's induce it a little bit further, and it's going to get us to energy. Okay, let's see. Where have I got to? So now, yep, now I have CPU energy. So it's computed energy based off of the data that's in there using the Teeds curve model. That's not enough. I want to get to carbon. To do that, I need to know, I know how much energy is consumed, but how clean or dirty is the energy in from that grid? There's a question being asked, is a cloud metadata only for public cloud providers? It currently is. Just feel free to answer. This is a good question. If you wish to enhance it, it's open source with like other data. Feel free. So we store everything as a CSV file. So if you store it in there, it's enhanceable. Um, so if we wanted to turn this to grid emissions, I need grid emissions. Let me zoom past here. So I'm going to use what time. Let me configure what time plugin. I'm going to add. Oh, I'm back here again. I'm in the proper one. I'm going to add the what time plugin. What time is it? Calls an API and it uses credentials, which I've already set up in my environment variables. I'm not going to add credentials in the manifest file. That's not a good idea. Now let's run that. This should have a little bit of a pause because it's calling an API. So fingers crossed. Okay, so that's worked. Let's check out computer YAML, and I should have a little bit more information at the end. And here we go, grid carbon intensity. So in this region, for this time, it was 372 grams of carbon per kilowatt hour. And then a little bit later, it was 434 grams per kilowatt hour. And a little bit later, it was 470 grams per kilowatt hour. So this is the emissions of the grid at this particular time. Finally, I just really need to like close this thing out. So I'm going to, in order to get the uh carbon, you need to multiply CPU energy by grid carbon intensity gives you carbon. So I need to multiply those two together. So for that, I'm going to use what we call a logic plugin, and we have a couple of these as well. So sometimes all you need to do is like multiply, divide, add, things like that. So we just got a very basic multiply plugin. Takes these two inputs and outputs it as carbon. I'm going to add that to my pipeline at the end. And then, oh, and then here you go. Gonna run this. Oh, it's calling the what time API. Yep. And then at the end, I should have carbon. So there you go, 9 grams there. And it went, what's the next one? 12 grams. So we've now computed carbon. Woohoo! Well done. So moving very quickly on, because I've got 12 minutes. One of the things, yeah. So have you compared the results of carbon reports the cloud providers producing to their customers? What was the result? No, there is no information about that is public. So we haven't really uh, uh, computed that in that way. And also the methodology of computation from a cloud provider is very, very different to the methodology you might use here. So that is a very interesting question, though. Then I think it's something that that'll be good to maybe as a case study in the hackathon is to take see how they differ in terms of one versus the other. So that'd be a very interesting case study to have. Here you go. I could talk for ages about cloud provider carbon reports, but I've got 12, I've got 90, I've wasted a minute. Let me go. Let me talk about how to actually build a plugin. So plugins are just code. They're just code in your that you call from your manifest file. So you need a place for your code to live. So you'd basically go somewhere, you'd make a directory. So I'm gonna I'm gonna make a directory called copy plugin, and inside there, I'm going to basically write my code. I've already got copy plugin open up as a Visual Studio Code. So let me bring that here. Oh, let me delete that and delete that. Glad that's off screen. So I've got copy plugin folder opened up here. Okay, couple of things I need to do first to kind of get copy plugin working. It's a node package, so I'm going to be building. So I need to write npm in it. For now, you could just whatever the default is, that's absolutely fine. And you also need a place to store your JavaScript code. So I'm going to do index.js. So I'm just going to create a JavaScript file there. And it's a very let me first show you how I would configure this plugin in my manifest file. I think that's a little bit easier. That brings it all together. So in my manifest file, here we go. I want to create a plugin that does that's just some very basic plugin that's just going to copy one parameter to another parameter. So I want it to copy CPU energy to energy because CPU energy I'm just going to treat it as energy. So I'm going to define my copy parameter here. I'm going to call the plugin copy plugin. That's what you would eventually install. The method on that plugin is going to be called copy. And here's some global configuration. So if keep existing is true, I want to keep what I copied from. If keep it existing is false, I want to delete what I'm copying from. So that's kind of like some of the global configuration there. But as I'm using in a pipeline, I also want to provide configuration at the pipeline level as well. And this is not something we've shown you before, but you can actually have like what we call node level config as well as global config. So I'm going to have a node level config here, which I'm going to say from parameter CPU energy and to parameter energy. It's a bit contrived, this example, just to show you how I would various features, but yeah, it's useful in that case. I'm just going to put it at the end of the pipeline. So now let's go back to where I was building my copy. Sorry, I should have done that first. I got a bit lost in time. I'm just going to copy and paste some code here and show you what it looks like. It's very basic and simple. Like a plugin in Impact Framework is very simple to generate. I've created a function. This is in JavaScript. It's a function called copy, and it takes global configuration. So when you call this is passed to this is when you initialize it. You need to provide some metadata. Right now, it's very simple. It's just kind of execute. But in the future, this will expand to allow us more options for yeah. Is the PUE factor encompassed in this energy computation? No, it's actually not. We'd love for people to either build a PUE plugin or enhance the cloud metadata plugin to report out PUE, something like that. That's an interesting hackathon idea, actually. I was hoping somebody would propose that. Then you have a function called execute, and this is where the bulk of your logic will go. This execute function is what is called when. Why can't I go to? Yeah. This execute function is what is oh my God, is what these inputs are passed into, and also what any configuration, node level configuration is passed into. This is where the meat of the function go. So you get past your inputs, you get past your config, and that's where you perform all of your functions. And then you just have to return an object which has your metadata and your execute function. We use functional programming paradigm here. Okay. So uh, okay, very important. Next step, just to kind of, because you're working locally, like how do you treat a local folder as if it's something you're importing into another system? You have to use in here called npm link. So as you build your plugin, just type npm link, and that makes it available as something you can like technically link into another package. So I'm going to go back into here, and I'm going to oh, back into here, npm link, and I'm actually linking all of these, but you can see at the end I've got copy plugin, and this, oh, I shouldn't have done that. Should I have done that? I should have done that. Hopefully the demo gods uh will save me. These gods. Um okay. So now copy plugin should be available for use inside my manifest file because I'm running it in here. So fingers crossed, everybody. This definitely worked this morning. 100% didn't have a problem. It actually completely failed this morning, but it worked an hour ago. So, yes. Come on, come on, come on, come on, come on, come on, come on. Yes. Brilliant. So I'm logging out some stuff here. So keep, yes, 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 yes. Wonderful, wonderful, wonderful. So you can see here, there's some data that's being passed out. These are the inputs that's getting passed into that inputs from the execute function. And at the bottom, I'm printing out the config that was passed. If we go back to the here, inputs is all of this stuff, and config is all of this stuff. Okay, so now you can play around, and now you're starting to see how you might actually build a plugin. So all you need to do is just adjust these inputs. That's your whole point as a plugin, is that you've been given some inputs. What do I do? Are you calling an API? Are you multiplying it with a PUE coefficient? Are you doing this? Are you doing that? That's all up to you in terms of the plugin. The inputs that you passed in are standardized inputs. Those names like CPU energy is we have like a standard place where we clearly define what that is. It's in kilowatt hours. It's we have so you don't have to be worried about the units of things. Um, in the interest of time. Not in the interest of time. I'm just going to copy and paste it here. So I'm going to do a little bit more. So this is a common pattern that we use here. So you grab the parameter. You got a global config here. I want to grab keep existing from global config and still have an execute function. The from parameter, the to parameter. And then basically I'm doing all that wonderful stuff of like copying what's in from to in this loop. Now let me go back into my main thing and now I'll run it again. Hopefully this should actually work. What a wonder. 18 questions. Wow. Great questions today. Let's definitely keep an eye out. I really it's a very, very active day today. Um and just showing you yeah, boom. Something weird's happened. I seem to have some outputs, but it's just energy, that thing I'm copying out. It's not all the other things that was there before. Now, that's a little bit of an aspect of how we've designed it. We actually need each plugin to output what it was passed in um, for now. So how we would do that in JavaScript in this particular case is I would just pass in the input, and that basically copies in the input into the output. And that allows us to build like plugins which intentionally don't copy stuff out, because you might want to intentionally filter data as you go up the plugin stack. Um, and very quickly, I'm going to be out of time soon, but I think I'll definitely have the time to finish. Um, And then what this should now be doing is actually doing its job. So if I go to computer.yaml, is this computer.yaml? It is. Yes. I now, as well as the CPU energy, I have an energy because and with the same value because I created a plugin which all it did was copy this into this. And just to complete it off, I'm going to go to the top of my manifest file. I've got global config, which keep existing is equal to true. I'm going to change that to false. And I'm going to just finalize my copy plugin. I'm going to paste the rest of my code there. And all I've already done is I've added in some logic. If keep existing is false, actually delete what was in the input. So let's just tie everything up in a bow. Oh, that was too fast. Oh, that was uncomfortable. No, it worked. So you can see energy is there, but CPU energy is now missing because I kept that keep existing as a false flag. So that was it. Okay, excellent. At time. Woohoo! That's it. That's the end of the demo. I just want to remind people, I know there's some very active questions in here. I just want to very, very clearly remind people that we do have a hackathon running, and if you would like to either take part in the hackathon, please sign up. But also, I'll be sending the hackathon participants end of this week, not this recording, but a better recording where I've actually recorded it of the actually maybe this one was not too bad actually, to be honest with you. Yeah, it was all right. No problems. So we'll be sending you a recording, but also more importantly, an actual tutorial where you can see all the commands that I ran. You can copy and paste. You can run it yourself. Yeah, that is what will be happening. So again, head to here, sign up if you want to make sure to get that material by the end of the week. Still very active questions typing away here. But thank you very much, everybody. And yeah, if there's no other questions, I think there's any other questions? If there's no other questions, I think I actually have to head off now and do some picking up of small children from nurseries. Yeah, thank you so much. Thank you.
Hassan,
Go
can
on.
you answer one very, very, very quick question?
Go on.
Someone was asking about what VS Code extension you have that makes the YAML at the top of your screen show show the condensed parts.
I
Do you have a
have
special extension?
I have no idea. Do you know what? I saw it on
Okay.
yours and I was wondering like what have you installed? And then it just I don't know. It just appeared one day in my
Okay.
Visual Studio Code. I swear. You mean this thing where it shows like
No, at the top of the screen, you've got
oh
it's showing the path through your YAML, the tree
oh
outputs. I don't have that.
you don't have that?
No, and someone's asking how they can
I
get
don't
it.
know.
So I thought maybe you had a nice
I don't
YAML
know, but
extension.
I also think
Okay.
I think it's a default thing because I haven't really played around with my VS Code. This is a new laptop, so
Okay.
I haven't really configured it. So it might just be you might have configured it out over time, but it probably is
Maybe.
a default configuration somewhere. Um, so wonderful. Thank you so much, Joseph. Let's make sure we get get those questions. I don't know if I'm worried if we end the call, do we lose the answers and questions?
I don't think we do, but I've copy and pasted them into a text file anyway.
Wonderful. Okay, awesome. Thank you, everybody. Please get involved with Impact Framework. Take part in the hackathon. We'd love to. We're very excited about this project, and I'm just so excited that you all joined us for us to show you just how excited we are. So wonderful. Thank you all. Bye.